In this lesson, we shall look at more concepts in vectors, and we shall start by looking at displacement vectors. The change in the position of an object is known as the displacement vector. In other words, if an object moves from a point A to a point B, then the vector which describes that movement is what we call a displacement vector. And the displacement vector shows both the direction and how far an object has moved. If we consider triangle OAP, consider this triangle OAB. Maybe that's triangle OAB. This is point O, this is point A, and this is point B. Now, if I want to get displacement vector AB moving from A to B, means that if I write AB, means the body was coming from A and going to B. So A is the starting point and B is the final point. And this will be according to my diagram. A, O, I move from A to O, then I continue from O to B. And this, I want to change the order of the letters because in most cases they will have given you OA, not AO. That will be, every time you change the order in vectors, put a negative plus OB. And this comes to OB minus OA if we rearrange this. So that's how we shall get direction vector or displacement vector AB. And that shows us that every time we're looking for displacement vectors, we're going to get the final position vector minus the initial position vector. So for example, let's look at examples about displacement vectors. The position vectors of A and B are 2, 3, and 5, 6. Determine AB. Now, in order to get the displacement vector AB, we're going to get the position vector of this minus this, which is OB minus OA. This is OB from here is 5, 6, write in column form, minus OA, which is 2, 3. And this means 5 minus 2 is 3, and then 6 minus 3 is also 3. So the vector AB is 3, 3. Let's look at the next example. The position vectors of P and Q are 5, 2, and 10, 1. Determine PQ. So PQ will be, you look at the last letter Q, that's OQ, minus the first one, OP. And OQ is, from the question, this one, 10, 1, minus OP, which is 5, 2. And this gives us, you subtract corresponding elements, 10 minus 5, which is 5, 1 minus 2, which is negative 1. So this is the displacement vector PQ. Let's look at the next example. If N is 4, 3 and NM is 8, 4, find the coordinates of the point M. We're looking for the coordinates of M, and we're going to use this displacement vector. We know that NM will be, you get this last one, OM minus the first one, ON. But for this particular case, we're looking for the coordinates of the point M, which is OM, position vector of M. So we're going to substitute. We know NM from the question. 8, 4 is equal to OM. We don't know OM, that's what we're looking for, minus ON, which is 4, 3. We're going to try and make OM the subject, and means this goes this side. 8, 4 plus, here it's a minus, crosses the equal sign, becomes a positive. 4, 3. This gives us 8 plus 4 is 12, and 4 plus 3 is 7. So we can, this is the position vector of M, but the question wanted the coordinates of the point M, so we can conclude, therefore, the coordinates of M, or the is or are, I don't know, is 12, 7. That's the coordinate for M. And that's how we use displacement vectors. Let's now look at what we call the zero vector. Now, the zero vector is also known as the null vector, and it is a vector with no magnitude and direction. It has the same initial and terminal points. And the commonest example of a zero vector is the position vector of the origin, which is denoted as O. Now take an example of, if I have a point, AB, I have a point A and a point B. So we shall have, this is A, this is B. If I got this direction vector, displacement vector AB, and I add it to BA, what I'll get 0, and this will be what we call the null vector. Because if I came from A to B, I'd move from A to B like this. Then I come back from B to A in this opposite direction. It means that I'll still end up at the point A, where I started from. That means that I have not moved in any direction, and the magnitude and direction in that case will be 0. So in summary, a zero or null vector is that vector which has the same initial and final points. In other words, there is no movement anywhere. That vector is said to be a zero vector. Let's now look at equal or equivalent vectors. Now, if A, or maybe I should use, if A is equal to x1, y1, and B is equal to x2, y2, then for these two to be equal, for A to be equal to B, it would mean that x1, y1 is equal to x2, y2. In other words, x1 will equal to x2 and y1 will equal to y2. So two vectors are said to be equal or equivalent if they have the same magnitude and direction. The components are the same. So we could say that equal vectors have the same magnitude and direction. When two vectors have the same magnitude and direction, we shall say that those two vectors are equal, and we can use this knowledge in calculations, like in this next example. Given that A is equal to 2x, 12, and then B is equal to 8, then 4 plus y. And they're saying if A and B are equal, find the values of x and y. Now we know that from the question, A is equal to B, or A is equivalent to B. So we're going to get A, which is 2x, 12, and equate it to B, which is 8, 4 plus y. If these two are to be equal, then this should equal to this, and this should equal to this. So we shall have 2x is equal to 8 divided by 2 divided by 2. Our x is 4. Likewise, we shall have this is equal to this. So 12 is equal to 4 plus y. And we're going to make y the subject. So that will be 12 minus 4 is equal to y. And therefore y is equal to 8. Let's look at the next example. Given that P is equal to 3a and 10, Q is equal to 9, 4 minus B, find the values of A and B if P and Q are equal. Now we know that P and Q are equal or equivalent, so we shall equate them. We have 3a and then 10 should give us 9, 4 minus 2b. So we're going to equate this to this. We have 3a is equal to 9 out of 3, a is 3. Then we're going to equate this to this. 10 is equal to 4 minus 2b. So we're going to bring this side. We have 10 minus 4 is equal to negative 2b. This is 6 is equal to negative 2b divided by negative 2 divided by negative 2b is equal to negative 3. And that's all about equal or equivalent vectors.